Now let's use our notes from the other day and answer these questions in a quick fashion. If someone asked you what is the sign of pi over 3, what you want to do, remember, is look at the unit circle, find a third of a pi. It's going to be right here. And you're going to be looking at, for this one, the y value. So this sign value at pi over 3 is going to be the square root of 3 over 2. Let's continue using this exact unit circle here to find the simplified exact values of sine, cosine, and tangent in given degrees or radians. First question here, they want us to find the tangent, the exact tangent of 30 degrees. So first thing I'm going to do is move 30 degrees on the circle. 30 degrees lands me here. I recognize this is the ordered pair. Remember, the tangent of anything is sine over cosine. So it's a sine of 30 degrees over the cosine of 30 degrees. Sine is 1/2. Cosine is the square root of 3 over 2. Now this is a complex fraction because I have a fraction and a fraction in the whole fraction. The easiest way to clean it up is to get the fraction out of the bottom. Multiply by the reciprocal. If you do it to the bottom, you have to do it to the top. Nice thing here, 2's cancel, those cancel. On the top, those 2's cancel. What I'm left with is 1 over the square root of 3. Now we cannot have square roots on the bottom, so I do have to clear that up. Simplify your radical by rationalizing the denominators. When you do that, you're going to get the square root of 3 over the square root of 9. The square root of 9 actually becomes the number 3. Therefore, the exact tangent, or the slope of the line created by moving 30 degrees, is the square root of 3 over 3. Now they want us to do the similar thing, the exact value of tangent, but for 60 degrees. So I find 60 degrees on my circle. I identify the ordered pair. It's sine over cosine, so that's going to be the square root of 3 over 2 divided by 1/2. To clean up this fraction, same thing, multiply by the reciprocal. This clears out nicely. All we're left with here is the square root of 3 over 1, which is just the square root of 3. Now let's take a look at this. They want us to find the exact values of cosine, sine, and tangent at 120 degrees. Okay, again, just go to your unit circle. If you move 120 degrees, you are going to land right here. Now if you look at the circle, you're going to notice that the answer here is going to be, the ordered pair is negative 1/2 and then square root of 3 over 2. So the cosine's easy. It's right here, negative 1/2. The sine is square root of 3 over 2. The tangent, we're going to have to crunch a little bit. Let's do sine over cosine and simplify. When you do that, what's going to happen again, all this cancels, 2's cancel. We're going to get the square root of 3 over negative 1. That simplifies to the negative square root of 3. Careful, use your gut instinct on this. If you draw this, the slope of this line as you read it left to right goes down. So the negative is incredibly important in this answer. Let's do another example. Find the exact values of sine, cosine, and tangent of a negative 11 pi over 4. A few key things. Negative means goes backwards. The other thing, this is an improper fraction, so it might be easier to view it if you make it mixed. So let's look at negative. 4 goes into 11 twice with a remainder of 3. So we're going negative 2 3/4 of a pi. So let's move that on the circle. If I go negative 2 pi, so there's negative 1 pi, negative 2 pi, 3/4 lands me right here. So look at your circle. Where are we really talking? We're at the original spot of 225 degrees, or 5 pi over 4. This ordered pair is negative square root of 2 over 2, negative square root of 2 over 2. So the sine value here is right here. The cosine is right here. The tangent is sine over cosine. So let's do sine, which is negative square root of 2 over 2. Cosine, negative square root of 2 over 2. This actually divides out into the number 1. So the slope on here is a positive slope of 1 is our final answer. Let's look at a few more. Here they want us to find the sine of pi over 4. So I'm going to move pi over 4 and I land right here. The sine value is the square root of 2 over 2. The next is the cosine of 5 pi over 6. So I need the x value. I'm going to move 5 pi over 6 and I land right here. The x value is right there, negative square root of 3 over 2. The last one here is they want us to find the tangent of pi. So I'm going to move pi units, which lands me right here. Tangent is sine over cosine. So I need to take sine of 0 over cosine of negative 1. 0 over negative 1 is 0. The tangent, therefore, here is 0, or the slope created by that angle movement is 0. Another type of example to show you is this. It says here, give two values between negative 2 pi and 2 pi, where the cosine of theta is equal to the square root of 3 over 2. Now, this statement right here says the cosine of theta, or the cosine of the angle, equals the square root of 3 over 2. So how you interpret that is they're telling you that the x value of the ordered pair is the square root of 3 over 2, and I don't know the y value. Now they want to know if you were to rotate around the circle negative 2 pi's, or from here go backwards 1 complete rotation, or if you were to go positive 2 pi, which would be forward 1 complete rotation, at what angles would you encounter the x value being the square root of 3 over 2? So let's first do the rotation of positive 2 pi. So if I rotate here at my starting point and I go a full 2 pi rotations around, where does that happen? Well, the cosine equals the square root of 3 over 2 as I rotate right here at 30 degrees. And as we keep going, we're going to see that it doesn't happen again until we hit right here at 330 degrees. So if they asked me for the degrees, I would say 30 degrees and 330 degrees. If they wanted it in terms of radians, I would say it's pi over 6 and at 11 pi over 6. So that's the forward rotation. But now what if we were to go backwards, if we do the negative 2 pi? So then from here, I'm going to go backwards 1 pi all the way to 2 pi's. If we do that, we're going to see where does this happen again, where x is the square root of 3 over 2. So as we do our first rotation, we're going to stop right here. So it's at the same spot, but be careful, it's not at 330 degrees. We just went backwards. So this little sector right here actually represents, in terms of degrees, negative 30 degrees. Well, if I wanted radians, that'd be negative pi over 6 radians. As we continue around the circle backwards, where they're going to hit the x value as the square root of 3 over 2 one more time, right here. Again, on the normal rotation, that's 30 degrees. But as we go backwards, this is actually a negative 330 degrees. Now, if I were to convert those degrees to radians, that would be negative 11 pi over 6. So those are the 4 values at which it happens. This is just a good example of showing you another way of interpreting the unit circle, where they're making you find the actual angle or radian movement given the x or the y value. Now be careful, if I had asked you, if the question had said the sine of theta equals the square root of 3 over 2, then what that means is on the ordered pair, I don't know the x value, but I know the y value. So you would go to your unit circle and you would find all the ordered pairs where the y value is the square root of 3 over 2, and list again either the degrees or the radians for where that happens.